Now we're going to look at an experimental study, and we're going to focus on identifying some of the main characteristics of a experimental study. Let's go ahead and start by reading the description of the study. Standard devices put inside blood vessels that assist in patient recovery after cardiac events and reduce the risk of an additional heart attack or death. Now, researchers perform an experiment in order to address the following question. Does the use of stents reduce the risk of stroke? The researchers asking this question conducted a randomized two-treatment experiment with 451 at-risk patients. And so here it is referring to 451 patients who are at risk of having a stroke. Each volunteer patient was randomly assigned to either a treatment group or a control group. In part A through F, we're going to focus on completing the sentences by filling up the blank. So in part A, we have patients in the blank group receive a stent and medical management. The group of patients who are receiving the treatment is what we call the treatment group. So again, in a research study, when we refer to the treatment group, this is going to be the group of patients, the group of individuals who are receiving the treatment. Now, if you feel more comfortable with having a definition for each of the words that we're going to be seeing in this example, you can go ahead and take out your textbook. In this lesson, we're going to be exploring those vocabulary words by looking at this example. Okay? Now, in part B, we have patients in the blank group receive the same medical management as the treatment group, but they did not receive the stents. And so, yes, this group of people are receiving some type of medical management, right? It is important to not harm the patients or the individuals participated in the study. So they are receiving some medical management. It could be a diet, it could be some type of medicine, but they're not receiving the stents. And so this is what we call the control group. Now, the control group is going to provide us a baseline for comparison. We're going to be able to compare the results that we see from the treatment group with the results that we're seeing in the control group. Now, let's move forward to part C. The blank is the treatments patients receive. In this case, it would be the stents and the medical management. This would be considered the treatments. This is what we call the explanatory variable. The explanatory variable is controlled by the researchers. This is going to be the expected cost in something else. This is going to explain the results that we see in the experiment. Okay? So in this case, stems are going to explain the results that we see in strokes. Are we seeing more strokes? Are we seeing less strokes? Now, in part D, we have the blank is the event of having a stroke. So this is what we call the response variable. And so again, the explanatory variable is a variable that might cause changes in the response variable. And so maybe it would be good to draw ourselves a picture. So the explanatory variable might have a change in the response variable. Okay, so in this example, again, the explanatory variable is the stents and the medical management. The response variable would be the event of having a stroke. On our previous example, the explanatory variable was amount of cinnamon that was given to patients. The response variable was the glucose level. Okay, so in that example, the explanatory variable, which is the amount of cinnamon, that might have a change in the response variable, which is the glucose level. Now, we have one more type of variable, which is called the lurking variable. And this is going to be additional hidden factors, or an additional hidden factor that might have an impact, that might influence the response variable. For example, what could be a lurking variable for this experiment? And that is the question that we have here in part F. What are some examples of possible lurking variables in the stent research study? So remember, the response variable in this study is the event of having a stroke. So what other variables might have an impact on having a stroke? I'm just going to draw an arrow in between here. What could be a hidden factor that has an influence in the response variable? Well, I'm sure that multiple ideas might come to mind. The first one that comes to mind would be diet. Okay, what diet are participants following? What else? Well, what about cholesterol levels? High cholesterol can result in a stroke. Again, there's multiple variables that we can think of. What about smoking? Right? What about family history? Or past history, medical history? What if we have some patients that had a stroke in the past? There's multiple lurking variables that we can think of that might influence the response variable. Now, let me make a remark. Researchers must design their experiment in such a way that there is only one difference between the two groups, the treatment group and the control group. Okay? And that would be the planned treatment. So the researchers who are conducting the STEM research study, I hope that when the study mentions that there was a medical management treatment, I'm hoping that that refers to a healthy diet, controlling levels of cholesterol, encouraging participants not to smoke, and so on. Okay, so that is the ways researchers can block those variables. Now, let me go ahead and talk about another way that lurking variables can be blocked. There's going to be some lurking variables that are going to prevent researchers to conduct a randomized treatment experiment. Now, you might be wondering, what is a randomized treatment experiment? A randomized treatment experiment is when the researcher randomly assigns patients to be in either the treatment group or the control group. Okay, so think about having all the participants. So in this case, let's look back at our experiment. We had 451 patients. Since it says that this was a randomized 2-treatment experiment, then we can assume that about 226 patients were randomly selected to be in the treatment group, and the rest, the other 225 patients, were selected to be in the control group. Okay. It's not always possible to conduct a randomized treatment experiment because there's some lurking variables that might have an impact in the response variable that we're trying to measure. So in this case, a randomized block design experiment can be used to block the lurking variable. There's going to be randomization still, but we're going to be blocking the lurking variable. Okay, and so I have a visual here that can help you see how we could block a lurking variable. Okay, so we're still talking about the experiment above where we have patients at the risk of having a stroke. Now, out of those patients, there's going to be some that are at low risk of having a stroke, and there's going to be other patients who are at really high risk of having a stroke. Being a low risk or a high risk patient of having a stroke, that is considered to be a lurking variable. Okay? And so what are we going to do? Well, we're going to separate the patients into 2 groups, and this is not going to happen at random. This is something that you would be controlling as a researcher. You would be separating the low risk patients and the high risk patient. Once this happens, you can randomly split the low risk patients in half. Half of them would go into the control group and half of them would go into the treatment group. Okay? Same thing with the high risk patients. Randomly split them in half. Half of them would go into the control group and half of them would go into the treatment group. And notice what happens here. Now you have the control group, and the control group has participants who are low risk and participants who are high risk of having a stroke. Okay. Same thing with the treatment group. You have low risk and high risk patients. And so now we're going to be able to see how the treatment, the STEMs, have an impact in both low risk and high risk patients. Now, let me introduce you to another important characteristic of experimental studies. In experimental studies, it is important for each group to be treated the same. It is also important that participants do not adjust their behavior just because they know that they're receiving the treatment. So for example, if our patients know that they are the ones who are receiving the stent, they might start adjusting their behavior. They might start thinking, if I have a stent, if I have doctors trying to help me prevent a stroke, maybe I should also stop smoking, or maybe I should start eating healthy, right? And so the behavior of the participants might have an effect on the response variable. And then we have the participants in the control group who would know that they're in the control group, who would know that they didn't get a stent, and so maybe they are not going to adjust their behavior, or maybe they are. Who knows, right? Again, but we don't want to see a change in their behavior. We're trying to test out if the stent is going to have an impact in having a stroke. Okay? And so to circumvent this problem, researchers use what we call a blind experiment. A blind experiment is where the participants do not know whether they are part of the treatment group or the control group. To make the study truly blind, researchers use a fake treatment, which is called a placebo. Okay? So on our experiment above, it could have been the case that researchers made all the patients believe that they did get a stent. Now, if you're testing a new drug the participants need to take, a placebo would be a fake pill that you give the control group so that they think that they're also receiving the drug that is being tested. Now, another option is to use what we call a double-blind experiment. And this is where both the doctors or the researchers and the patients are unaware of who is or is not receiving the treatment. Okay? So again, neither the researchers nor the patients know whether they're in the control group or the treatment group. This is what we call a double-blind experiment. So we're going to go ahead and look at one more example together. Here we have a experimental study, and we're going to go ahead and read the study, and then we're going to identify the following: the population, the sample, the treatment group, the control group, the explanatory variable, the response variable, and any possible lurking variables. We're also going to answer the following two questions. Is the experiment a blind or double-blind experiment? Is the experiment a randomized experiment or a randomized block design experiment? Okay, so let's go ahead and read the problem. As we read the problem, you can start thinking about how we're going to answer the questions below. Researchers want to investigate whether taking aspirin regularly reduces the risk of heart attack in men between ages of 50 and 84. 400 men between the age of 50 and 84 are recruited as participants. The men are randomly divided into two groups. One group will take aspirin. The other group will take a placebo, a fake pill. Each man takes one pill each day for 3 years, but he doesn't know whether he's taking aspirin or the placebo. At the end of the study, researchers count the number of men in each group who had a heart attack. At the end of the study, researchers count the number of men in each group who had a heart attack. Okay. So what is the population here? Let's try our best to include as much detail as we can. So we're talking about men between the age of 50 and 84. And so our population is all men between ages 50 and 84. What's our sample? Well, our sample is 400 men between the age of 50 and 84. What's the treatment group? So notice it says men are divided randomly into two groups. One group will take the aspirin, the other group will take the placebo. Okay? So the treatment group is the group of men taking the aspirin. And what is the control group? Well, the control group is the group of men taking the placebo. Now, I'm going to go ahead and fast forward to the question that we have here below. Is the experiment a randomized experiment or a randomized block design experiment? Well, notice it says the men were randomly assigned into two different groups. In this case, we're talking about a randomized experiment. Again, why? Because the men were randomly separated in two groups. And so the key here is that this separation happened at random. Okay. And if you want to include more detail, you can say we're separated into the treatment group and the control group. That's what I mean when I write two groups. I just wanted to answer that question because we just read that sentence as we were answering part C and D. Okay, so what would be the explanatory verbal? Okay, the explanatory verbal would be taking the aspirin. What is the response verbal? The response verbal is the event of having a heart attack. Okay, and so in this study, we're seeing if the explanatory verbal, taking aspirin, has some effect on the response verbal, which is the event of having a heart attack. So what are some of the possible lurking verbals? We mentioned some earlier, and so that could be unhealthy diet. We mentioned smoking. We also mentioned medical history. Again, there's multiple lurking verbals. We're hoping that the researchers are thinking about how to block these lurking verbals. Now, last question that we have here is the experiment a blind or double-blind experiment? Looking at the description, we see that it was mentioned that the participants didn't know whether they were taking aspirin or the placebo. So the participants didn't know if they were in the treatment group or the control group. Now, nothing is mentioned about the researchers knowing whether participants were in the control group or the treatment group. So looking back at this question, we're going to answer that this was a blind experiment because the participants didn't know if they were in the control group or the treatment group. And again, we cannot assume that it was a double-blind experiment because we're not being told whether the researchers knew if the participants were in the control group or the treatment group. As we conclude our lesson, I encourage you to go back to the learning objectives. Ask yourself, can I identify the difference between an observational study and an experimental study? Can I identify the main characteristics of an experimental study? And can I identify explanatory verbals, response verbals, and lurking verbals? Okay. You can use our activities or the WAMAP homework to test your understanding about this lesson. Go ahead and find an example that can help you test this learning objective.